My name is Allen Rabinovich. I'm a engineer on the YUI team, and this is the teller to my pen, Trib Bridges. He's our Flash guru. And what? I'm sorry, I shouldn't have called you that. Boxes, arrows, and code. That's his official title. He draws boxes and arrows, and then he writes code. So this talk is about the upcoming, and by upcoming I mean we don't have a release date yet, version of the charts component, the one that you probably have seen in YUI 2. And this is going to be the YUI 3 version of it. It's going to be renamed Infographics because the functionality is actually going to be expanded beyond just the charting capabilities. And we'll talk about what that functionality will be quite a bit in this talk. And so just to be very clear, this is just a talk about what's coming up. So in some sense, this is vaporware in the sense that it hasn't been built yet, but unlike vaporware, it is actually being built, and we promise you that we will deliver, but we can't tell you when yet. So just to reinforce that point, the infographics component is in production. We don't have any release dates, so don't ask. And we're not going to do any demos because we don't yet have any working pieces to demo for you. So that sounds like it makes for one boring talk, but what I thought... Done. Over. Dinner is served outside. So I think instead what we're going to do is give you an idea of how we go along, how we build components. And sort of the first part of that story is we start with setting goals. You know, what are we setting out to build? Why are we building it? What are the reasons behind the initial set of decisions we're going to make? Then really defining the scope of, how much are we going to build in a particular release, what sort of features we will introduce, what's going to be left either for next release or just left out altogether. And then we'll finally actually look at the architecture of the YUI 3 charts. Quite a few things have changed from YUI 2 going to YUI 3. And those, we think those are sufficiently interesting for you to hear about to sort of get an idea of how architecture decisions are made. So let's start with the goals. Sort of where did we start? Well, one of the primary goals in many projects is to fix the problems of the previous version of the same project, and that's really what we're doing in YUI 2.8 and YUI 3. The next version of the charts is really addressing the shortcomings of the previous component. And if you caught the hybrid talk yesterday, we talked about the shortcomings of the hybrid architecture in previous versions. So dealing with the problems in the hybrid architecture and improving them in the next version is one of the goals. The next goal is reducing the footprint of the component. So I think right now the charts are 86 kilobytes, and you sort of get the whole charts package, whether you want it or not. We're going to modularize that, sort of turn it into smaller pieces that you can pull into your projects as needed and not keep such a large footprint around. We'd also modularize the structure of the YUI 2 charts in the YUI 3 release. The problem with the YUI 2 charts is that everything is very tightly coupled together. All of the pieces are sort of, all of the data and the model and the view, everything that the chart is, all of the individual subcomponents of a chart are all part of the same interface, essentially, the same API, and it's very hard to control pieces individually, and that's one of the problems we've set out to solve with this release. And of course, another obvious goal is to expand the functionality. So we'll talk a little bit about where we get the ideas for what new features we need in the new component, but it's become pretty obvious to us that there are many more features we need to add. In addition to features, we also need to add actual tools, things that haven't even been in the charts release, and that's sort of where the whole renaming goes, that when you go beyond charts, you start thinking about larger space of information visualization, what new tools exist in that space. So that's also among our goals. So when you set the goals, you kind of have to define the problem space first. So with this release, we thought, well, how do we figure out what problem we're trying to solve? What is the whole space of things we want to address? And the first thing you need to do in that, when you're dealing with visualizing information, is to sort of classify all the possible visualizations. figure out, what's actually possible. What kind of information sort of gives itself easily or not so easily to visualization. And then, once you've defined this huge space of problems for yourself, you want to narrow it down by what's actually computable, right? There are lots of ways of visualizing information. A portrait is a visualization. A child's drawing of something is a visualization, but not a lot of those things are actually can be turned into computational structures. So that's something you have to sort of narrow down and say, okay, this is something we can build. This is something we absolutely cannot. And finally, after figuring that out, you want to narrow it down further by possibility. So we have limited developer resources. We're a finitely sized team, and we have a finite amount of time. We want to get this out to users at some point, right? Not keep working on this for years and years and years and never deliver. So we further have to narrow down the field of things we need to work on, specifically for the initial release, and then sort of think about what goes into the next release, into the next one, and so on. And so to just sort of quickly run through those points, when we looked at the classifications of visualizations, there are many of those around. This is one of the more popular ones. I don't actually like it because it makes no sense, but I just put it up there. We didn't use it as our basis, but it's called a periodic table of visualizations. It has every sort of visualization available to you. I don't think the periods and the rows actually mean anything, but things are roughly grouped together by sort of the types of information visualization. Some of it, is very familiar. There's some line charts up there. There's, the tree map, and so on. But that's, a lot of these are sort of like learning map. Like a lot of these are not really computationally feasible. They're not things you can turn into an API that a developer can use to build out a visualization in a consistent manner. So we needed a narrower taxonomy, sort of narrowed down to what's actually possible to be built on the computer. And we sort of narrowed it down to 4 categories. The first category is quantitative visualization. That's the more popular one. You're probably looking at 95% of all cases of visualizing information. And we're talking about Cartesian charts, visualizing any numerical data. The bear is getting angsty, so look out. Visualizing any numerical data. Keeps like I have a lazy eye. I keep wandering in that direction. It's very large. Can we cut that from the video? So visualizing 2 or 3 dimensional data sets, or even n-dimensional data sets potentially, but primarily dealing with numerical data. There's also relational visualization. The more sort of famous examples of that are things like flow charts or Gantt charts that don't necessarily represent a numerical information, but represent a flow of data or relationship between different elements. That's a little sort of less easily computable, but it's still reasonable to come up with a way of structuring that with a kind of a programmatic interface. The next one is geospatial visualization, which is quantitative at its base. You visualize numerical information, but you visualize it on a map, and that's also been very popular recently with with all the diseases spreading and all. People want to see where the centers of the diseases are and where the most sex offenders live in the 2 square mile radius. So all of these things that can be placed on a map are geospatial visualizations. And finally, dynamic things. So think about dashboards. Think about things that represent live feeds of information, traffic to a website, the value of the stock market. So things that update with live streams. So they're also quantitative visualizations, but distinctly different because they represent, potentially one piece of data at a time. So think like an analog or a digital gauge, a VU meter. All of those things represent numerical data, but represented at the current state rather than a historical state. So those are the four sort of basic categories we plan to expand the YUI3 charts in, and eventually in YUI3 infographics you will see visualizations from all of these categories. But like I said, you want to narrow it down further because we are, there's very few of us and we have finite time. So where do we start? We need to narrow it down to the initial release and narrow it down in such a way that the basis that we build out is going to be extensible and usable by all the other components we're going to build in that space as time continues. And so, after sort of much thought went into it, we looked at what we can build in a reasonable amount of time and what people need most, what our users, what our developers are actually asking for most. And we settled on essentially the entire space of the quantitative charts. And that includes a fairly large set of different visualizations, but they're the primarily the Cartesian charts, so things like line and area charts, histograms, bubble charts, spark lines and spark bars are also in that category, and sort of the less the non-Cartesian versions of the same things, which is the pie charts, radar charts, and tree maps. So all of the other ones, just to give you an idea of what goes in other spaces, what I just discussed are these. These other, the geospatial, dynamic, and relational, and those will eventually become part of the package, but they're not part of our initial plan. But we have to keep them in mind when we think about how we design the architecture of these components. So the other sort of thing I wanted to show you is that when you think about these components, it's useful to sort of draw out every possible piece of functionality you want to include in that set. So this is an example of a picture I would render for Cartesian charts. So sort of thinking about every single feature that may or may not go into the Cartesian charts design. So I would draw something like this, which includes every kind of chart you can plot on a 2D surface, sort of little illustrations of what's possible, different types of markers and bubble charts and filled area charts and multiple axes and so on. So that gives you kind of a good idea of all the bases you need to cover with a component when you're thinking about how to architect it. Similar things for the pie charts, the tree maps, and so on. So like I said, limited developer resources, finite time, and requirements. What do people ask for most? What do we need to get to first that people are asking for? And what's best to provide a foundation for any future development we're going to do in this area. And so quantitative charts is what we narrow it down to. And at that point, when we say, okay, quantitative charts is what we're working on, let's start building it. Let's start architecting it. Let's start making decisions about the architecture. So, the first question, like I said, we're going to ask is what was wrong with the YUI2 charts? Well, awkward hybrid foundation is one thing. The modularity, exceptionally low, it was just a few modules, and then they had a bunch of styles and parameters and properties you could configure. But in terms of sort of working with individual components, that wasn't really an option in YUI2 charts. The fact that the data and the view were coupled, so you basically passed the data provider directly to the chart, which was also your view of the component, and that didn't really make for great interaction for the developer. It was a little confusing, and you couldn't really deal with data on a more granular basis. And it was lacking in some of the very essential features, as we found out. And how do we find out such things? Well, we talk to people. Internally, we meet with the teams that use our components. Some teams that have components exposed to the outside world, like web hosting, they use YUI2 charts. There are also internal teams that that only work within Yahoo, so people who do data analytics and so on also obviously use a large dose of data visualization components. And all of those folks that we've met with, we've specifically asked them what features they need to in a component like that, because they have real life problems and real life questions about these components. So those are those are the folks who have helped us define what features are missing. And, obviously external developers. External developers are contributing everywhere. So whenever we see a message or a bug filed by an external developer, or, like I said yesterday, the most passive-aggressive way, a Twitter message, saying something like, oh, I wish YUI2 charts had, such and such feature. And then, we actually look at that despite, thinking, oh, that's really passive-aggressive. But we do take all of that into consideration. We ask, well, why do you need that feature? What's the actual problem you're trying to solve? I'm very judgmental. Yeah. So those are, those are the things we needed to address, and that's where we approached the problem. So first, redesigning the hybrid foundation. So in YUI 2.7 and below, the hybrid components looked roughly like this. They used Flash Adapter, which was our wrapper around Swift Object, which is kind of a more popular way to embed the Swifts. But it turns out Swift Object is very, very complex for our purposes. And I covered this in the talk yesterday, so I'm just going to go through this briefly. Swift object used some non-standard elements. It had some issues with initialization timing that were hard to resolve. It didn't provide resolutions and fire once capabilities. And the other issue we sort of created for ourselves in Flash adapters, we restricted the amount of configuration you could do. So it was actually very difficult for us to build the charts on that foundation. It was very inflexible, as it turned out. So the hybrid foundation looks much simpler now. We've created our own Flash player wrapper called Swift, which is part of YUI 2.8 and going to be in YUI 3. And Swift is much lighter weight than Swift object. It deals with all of the initialization timing. It has the fire once event firing capability. It only uses the object tag, which is the standard way to embed Flash, and it really opens up all of the configuration possibilities, making it very flexible. So the hybrid foundation has already been redesigned. We redesigned it for the other hybrid components, and that sort of provides us a good step into basing the new version of charts on that much more flexible hybrid foundation. The next thing we did is we introduced modularity. So consider a typical 2D kind of histogram visualization. You could say, oh, this is just a histogram of two pieces of data plotted in year category with some numerical values. The reality of this is that everything here is a subcomponent, and you have to treat them as such if you want to give the developer maximum flexibility, right? So you have your axis, which is really a separate component. It renders completely separately from the chart. You have your grid graph, which actually is dependent on the axis, but also renders separately. You have your column graph, which is kind of another separate piece. You have your legend, and so on. So all of these things are separate components, and we have to treat them as such and design the architecture of the new charts in a way that will allow the developer to treat them as separate components. So how do we do that? Well, at the lowest level, we have renderer, which takes care of, just kind of a side note, the architecture I'm discussing is within the Flash player, so this is the ActionScript-based code base, but the reality of it is that all of that is going to be wrapped using the hybrid component foundation and available transparently to the JavaScript developer, so this directly applies to how the JavaScript developer will see the structure of their components. The renderer within Flash player takes care of some of the things that a basic display object within the Flash player does not, namely dealing with resizing the components correctly and sort of dispatching the resize events when the components are resized, figuring out the redraw of the component. So if the data has changed, you need to fire a redraw. If the scale has changed, or some changes that resulted in a redraw, and finally also styling the components is sort of a regular display object is a graphic primitive, but in our case we're working with components that have different styles, right? That have if it's a text label, it would have a font or color, rotation, thickness, and so on. So the renderer takes care of assembling these styles into objects and providing methods for setting and modifying the styles. Now, the renderer is at the basis of all of the subcomponents of the charts package. So, one of the subcomponents is the Cartesian graph, which all of the individual Cartesian graphs inherit from. And the Cartesian graph provides the pointers to the actual data that is used to draw the graph. And we'll talk about how the data and view are connected, and we sort of decoupled the two completely and then created connections between them. And it also provides, for the specific base style. So the styles cascade in the sense that, each component that inherits from Cartesian graph has all of the Cartesian styles in addition to styles that are specific to that component. So Cartesian graph provides the base styles. Then individual graphs would give you specific styles or additional pointers to data. And again, we'll talk about that. Some of these components, so for example, the bar graph that you saw, right, it actually has more data than just the x and y values, right? For y values, it has multiple sets of data per each x value. So it was like 2 columns per each x value. So you have to provide for individual Cartesian graphs sort of these exceptions where there's additional data that needs to be displayed on the graph. And finally, a container object that's used for laying out all of the individual components on the chart, and we'll talk about how the layout system works. And skin is part of the style lineup, but it's just a way to skin your components if you wanted to tile images in the columns or programmatically add a gradient or a color and so on. So that's what the the skin subclass takes care of, but they're all renders. They all need the same rendering capabilities that every other component that's visualized on the screen does. So that's the rendering basis. That's sort of the components that are used to render the graph visually on screen. So now we get to that point where, well, how do we deal with the data and the view? Like, how do the data and the view relate to each other? Well, let's look at the structure of Cartesian data specifically. So specifically for Cartesian maps, Cartesian charts, this is a very interesting question. So here's your typical Cartesian graph with two graphs. One plotting this particular key set in the table, the other plotting the second one. Really simple one. And notice that there's something very special about it, right? So your horizontal axis is related to only one key in your table, so it only plots the year. But your vertical axis actually covers two keys, right? It covers both the region 1 and the region 2 profits. So it's your vertical axis is related to two keys in the table, and that's how the minimum and the maximum for that axis are computed, right? They're computed based on two keys in your data set, not just one key. So you have to take that into account when architecting the connections between the data and the view to make sure that creating the axes and creating multiple axes potentially for a Cartesian graph is a completely flexible, transparent process. So the way we do that is first we establish sort of the top data source, the one that contains all of the information. And that's, in our case, is something called chart data provider. So it contains all the source data. It's essentially that table right there. It gives you convenient methods to extract a single column in the table. So you just can pull out a single key in the table and modify a single key in the table without actually changing the whole table. If you have thousands of values, that's potentially problematic. It also, provides all of the events. If the data has changed, it will send an update event, which will then propagate and create, cause necessary redraws in the view. So that's the basis. That's the chart data provider. And the next data class that's using the chart data provider is the so-called axis data. So the axis data provides data for an individual axis, and it provides the keys that point to that particular key's data in the chart data provider. So like we saw, a single axis can be keyed off of multiple keys, right? And it has to include all of them. The axis also includes sort of the cached version of the minimum and maximum values for that for that range of data, so that they don't have to be recomputed every time if the user resizes the graph and so on. It also gives the user the capability to turn off the automatic computation of the minimum and the maximum if they wanted to create sort of their own viewport, a custom set minimum and maximum on a given axis. And it also has an update event. Like if the user didn't change the source data but changed the minimum and the maximum on the axis, you still want to want to do a redraw without actually modifying any of the data. So that's relates to a particular axis. That picture should have appeared first, so kind of things happened in reverse, but you get the idea. Now, the key is that the axes and the graphs actually have separate pointers to data. So, and what that allows you to do is create graphs that have multiple axes, trivially easy. So this is perhaps not the best example, but just to give you an idea, so the blue graph is plotted against this axis, and the yellow graph is plotted against this axis. So there are actually now two axes on a graph. And this is a pretty frequent case, especially if it's two different sets of data. And they give you two different sets of information. And in this case, all we've changed is that one axis is keyed off of just one key, the other axis is keyed off of the other key. And that gives you a lot of flexibility of how you position your axes, how you position your graphs. Now, the graph itself only relies on a single piece of data, right? So a graph is much less flexible than an axis. It can be keyed off of exactly one x key and one y key, especially something like a line graph or an area graph. So Cartesian graph is the component that uses axis data to basically connect to the data source, and it has pointers to its x-axis data and y-axis data. So basically, you tell the Cartesian graph what the data sources are for its x-axis and for its y-axis, and then you tell it specifically in those data sources what a specific x key and the y key that they're actually portraying, right? They're actually visualizing. So that's the simplest case. That's a line graph. A column graph like that would be a little more complex. It has, each sort of unit in the column graph has one single x key, but in this particular case, they plot multiple y keys per x key. And so you essentially modify the Cartesian graph to include a y keys property that allows you to point at multiple y keys for each x key. Furthermore, there's something called a bubble graph, which is actually a three-dimensional graph, a 2D surface, right? So you have bubbles that are plotted against x key and y key, but they also have a third dimension. So it's not enough to just, to just give them, multiple keys for the y-axis. This is actually a separate dimension altogether. So all you need to do is basically create a z-axis that never actually gets visualized, right? There's no axis on the screen. And then provide the key for within that z-axis that the bubble sizes would depend on. So there are minor modifications that really only modify the pointers to data without actually modifying the view. So the view and the data are completely separate from each other. And that's incredibly useful, and that gives you sort of a whole wide range of ability to make small changes to your graphs, to modify viewports horizontally, vertically, add multiple axes, add multiple graphs, stack multiple graphs together. And while we're talking about stacking multiple graphs together, let's also talk about the layout. So on one hand, we're giving the developer all this freedom and saying, okay, everything is individual components now. You can have as many axes as you want, as many graphs stacked as you want. But the reality of it is we do want to constrain them to a layout because there are certain laws that guide how charts are drawn, right? So you always want your x-axis to be horizontal on the bottom, your y-axis or on top, your y-axis to be on the left or on the right, and the graph needs to be plotted between those two axes. Otherwise, visually, it just doesn't make sense if the axes are somewhere away from the graph. And so you want to create a layout framework that's sufficiently flexible to include all of these possibilities, but also constrain them to making it look like a chart. And so this is the so-called border layout, which is fairly standard. But it consists of separate individual pieces, right? So on top, you can have either vFlow or vLayout strategy. By the way, one thing to point out is that each of these things are containers. So it's all the same container that we saw earlier, the one that inherits from render. And all that container does is essentially takes on a particular strategy, particular layout strategy. So in this case, the container on top can take on either a vFlow or vLayout strategy, which allows you to lay things out vertically. The container on the right or on the left would be horizontal flow or horizontal layout. The one in the middle is a stack, or I just called it chart, but it's some kind of a more meaningful name than that, which is a stack of components. And the whole thing is also a container, which just has all these properties: left container, right container, top and bottom, and center. And that's your entire border layout. So that's a very flexible system. It allows you to stack the components as you see necessary, right? So you can imagine you can have one axis here, a couple axes here, maybe a title here, maybe a legend here or on top. So that really gives you all the spaces you need to place the pieces of the chart without sort of making it without giving it too much freedom. And so, like I was saying, the layout looks like this. There's the container, which uses one of the three strategies. Well, there's more than that. I think I just omitted some. So that's it's a really flat system. There isn't a lot there. There aren't a lot of different container elements. There's no HBox, VBox. It really keeps it very flat and very simple and flexible at the same time. So that's the layout, and that's essentially sort of the big highlights of the architecture. Now, in addition to sort of thinking about how these pieces are going to be implemented, we also think about what new features are brought in, both by these architecture changes and also what new features need to be implemented in these new charts packages. So some of these new features have to do precisely with redesigning the chart. So in YUI 2.8, where the architecture is still the same as it was in YUI 2.7, because of the very urgent internal requirements, we needed to add capability for multiple axes. And we did. We added capabilities for 2 axes. But because everything was coupled together, right, all of there was no modularity in the component, I don't remember, how long did you spend adding the second axis? Like a month, probably. Right. So it took a very long time. It was very difficult. And it was very awkward because imagine styling, so when everything is in a single component, right? So you had your chart, and if you wanted to modify, the axis color, you had a style called axis color. Now you add a second axis. What are you going to call that style? Second axis color? Which is, I think, what's actually happened. Because of the internal requirements, they asked us to deliver a component very quickly. We didn't have time to do the re-architecture. So in 2.8, you have this really awkward way of defining 2 axes, defining a style for each of those 2 individual axes. That really makes no sense. So,
Not that awkward. The biggest problem of it was there was just a lot of on-the-fly re-architecture, which is probably never really that great thing to have to do. But it is limited in what it can do, i.e. you're limited to 2 numeric axes, be it a Y or an X. And with a more modular approach like we're taking now, then it can be limitless insofar as you can design it and manage your space.
Right. So that, the multiple axes with this new re-architecture we sort of get for free. We get a lot more flexibility into how the components are placed and positioned in your view. We also, and this is kind of a function less of our architecture and more of the fact that the Flash player coincidentally has advanced. Flash Player 10 that just came out this year provides much better capabilities for working with text. So things that were very hard to do before, like rotating device fonts within the Flash player, became much easier. And now we can actually add advanced styling for the graph labels, which a lot of internal properties and as well as external developers asked us for. Yes?
So are you using the Sparks library in FlexForm?
No, we're not actually using any of the skinning. Right, that's actually worth pointing out.
FlexForm library.
Yeah.
Because you're using Swift, right, for the rendering.
Yeah.
Right, but we're not using any external libraries. And this is worth pointing out. So when I was talking about render, one of the things that YUI 2.8 and below used is something called UI component, which is actually a proprietary class that Adobe wrote themselves, which we weren't able to provide as open source. So it kind of started there, and there was this chunk of code within Flash that we supplied as compiled. We never actually gave you the source because it wasn't ours to give away. It can be distributed as a compiled version, but not as open source. So now we got rid of all proprietary pieces. Now this is all actually truly open source. There are no Adobe pieces in this, and that's actually the response. We're not using any external libraries. This is all our code. No.
Another advantage of that is as an open source developer, if you wanted to submit changes to GitHub or something, you're not responsible for an additional framework. It makes the level of participation.
So you just use the ActionScript library?
Yeah, just the base level, absolutely. So another thing that sort of we got for free is actually stacking charts on top of each other, right? With the other older charts, you had to provide individual series and essentially a method to plot them. Now you just create your own charts. You figure out what specific data they're showing, and then just drop them on as individual components. And you can stack them and change the display order dynamically. You can change display order on the fly. So you wanted to bring one chart out, you can do that, no problem there. And other new features that are sort of across the board that are not specific to the architecture or the components that we're planning to work on is a variety of widgets. So things like a zoom widget, essentially a tool that allows you to select a region of the chart and then passes the events from that region back to your code, so you can actually change your data source and replot the chart or do whatever you want. That's flexible enough that you can have multiple charts on the page and change one based on the information from the other. I think if some of you saw the Flot demo yesterday, so that sort of interaction. Think stock charts, right, where you select a chart region on the bottom and you plot it on the chart on top. Things like that. Changing cursors, tooltips, markers, all of that is planned as part of the release to really make it very feature-rich library. Flash allows local.
Things with such advanced features, if you don't want to wait for us to do it, we will have all the advanced infrastructure exposed as well as the API. So
Right. You can always add. Right. Or you can contribute code. I've got these CLAs right here. Yes.
Regarding like plugins versus the core functionality, are you trying to figure out what's core to this and what you be able to add to your plugins?
Right. So essentially, we're still working on that. That's still an open question. But yeah, we're looking at what's actually going to go into sort of the core Swift, or what the common combinations of functionalities are. Since that's really only essentially amounts to rewriting build scripts to include or exclude certain pieces, what will likely provide is multiple versions of different things bundled together. The problem with Swifts as opposed to JS code is that we can't actually do that dynamically easily because it's compiled code, loosely compiled code, but nonetheless we can't compile it on the fly. We have to provide pre-compiled versions of it. But yeah, I mean, we're going to try to make it as flexible as possible. So the other thing I wanted to mention is that as a Flash Player 10, you have local file access, so you can actually save a file in the user's machine, prompting user input, which would allow us to export files and open files from the user's machine as well. But that's kind of a separate story. Flash does great PostScript printing, so you can actually print the charts instead of just printing the web page with images in them. It's actually interesting. Our marketing folks have a lot of requirements in that area where they get their data report chart on the web page, and then they want to copy it and stick it into their PowerPoint presentation. They don't know that the print screen key exists, so it helps if we can actually give it to them as a file. So that's something that's a feature that's definitely going to be there. More advanced animation, so really using Flash for what it's good for. A lot of the charts can benefit from animation if you actually show how the data changes and so on. If you can actually tell it to animate from one data set to the other, you can easily build historical graphs where if you drag I think you guys have seen this has been one of the Google's projects, is visualizing data over time, where you drag a slider and the graph shows you the changes. So here you can build things like that just using the tools that we give you within the component. Another thing I wanted to show you quickly, we haven't built it yet. We're still building it. But you can test things before you build them. And the way you do it is you just write the code from the point of view of the developer who would actually be using these components. And it doesn't have to be complete and very detailed, but it gives you an idea whether that actually works. So, here's an example of a code our developer might write. They'll create a new chart, set its width and height on the page, grab a data provider. This might mash up with the YUI data source. Again, not very precise in terms of how it would actually work there. Great. So they have their data provider. They would create a couple of access data classes. One for the numeric axis, keying off the profits. One for the category, keying off the months. Then they would actually create the axes objects themselves. Add the axes objects to the containers on the chart. Create a line graph, keying off the profit data and the category data. Add the line graph to the center stack. Done. They have their chart. They've created their components individually, placed them on the chart. Fairly easy to use. So that's how we sort of sketch out how the chart would actually be used. And again, this isn't final version by any means, but that gives us a good idea of how things like that proceed. And finally, we do partial releases. We do sub-releases internally, so people we actually work with internally, we sort of get them the releases out to make sure that they can actually use it and try it out. We also have GitHub. Once we have more functionally complete sets, we'll actually start putting this out on GitHub, which should be fairly in fair short order. Like I said, I'm not going to name any dates, but that's pretty cool. And another thing we do is we actually ask our specifically internal developers, sort of, what is it that you're actually trying to build? Show us, tell your UAD to send us the screenshot of the exact image of what you want to build, and then we try building it. Can we actually build it? Not yours though, so don't ask. But we'll build it ourselves and actually try it out, and that's also a really useful tool to have when you're building components, to actually do it for your developers, sort of get into their shoes and do their work for them, and then you don't have to listen to their stupid question. No. So that's
I don't judge.
so that's our process, and we certainly like to hear if you have the usage for data visualization in your projects. We love we'll love to hear more ideas. We'll love to hear, what other features are notably missing, what sort of things you don't see that's possible with this, with this architecture, with this feature set. So let us know. You can let us know right now. You can let us know through all of the multiple ways to connect to us and so on.